Welcome to the High Voltage AI podcast. This week, we've been on a real deep dive, part of the special series in the High Voltage AI newsletter on Substack. We've been looking at overhead and underground construction, why we use them, their characteristics. We kicked off Monday talking about the Small Modular Reactor engineering revolution. Tuesday was all about passive safety systems, factory manufacturing. Wednesday, we got into grid integration, industrial heat uses. Yesterday, Thursday, advanced materials controls, construction systems. And today, Friday, we're really bringing it all together. We're aiming to build you a comprehensive action plan, how to build a successful small modular reactor career, the steps, certifications, the industry connections you need. And, to really make this concrete, let's talk about Sarah Chen. Her story, it's pretty compelling. So back in 2023, Sarah moves from automotive manufacturing over to the Scales module assembly team. Big switch. But what she found was her background, her Six Sigma quality control experience, is exactly what nuclear manufacturing was looking for.
But, and this is key, she didn't just jump in. She did the required training first, National Regulatory Commission required nuclear fundamentals, and she got her health physics certification. Okay, so fast forward just 2 years, now she's leading quality assurance. For the first commercial small modular reactor production line, she's earning, get this, 40% more than in her old auto job, and working on tech that could genuinely transform global energy. So Sarah's path, it wasn't just luck, right? It was a deliberate strategy, mixing her existing skills with that crucial nuclear-specific training. And that's exactly what we want to help you figure out today.
Yeah, that's a great example. And what's really fascinating here is just the sheer scale of the opportunity Sarah's story points to. I mean, the small modular reactor industry is projected to need over 80,000 skilled workers by 2030. That's a huge number. And when you look at salaries, they're very attractive. You're talking maybe $75,000 a year for technicians, climbing up to over $180,000 annually for senior engineers. And it's worth pointing out, current nuclear pros often get a 20 to 35% salary premium compared to similar non-nuclear jobs. Plus, if you connect this to the bigger picture, the industry's facing this big retirement wave. We're expecting over 35,000 openings just in the next decade from that alone. Right, so this talent shortage means there's a clear pathway for people transitioning, and it's proven. Companies like NuScale, TerraPower, X Energy, they've already hired over 2,000 engineers from aerospace, automotive, oil and gas, renewables, often with specific training programs set up to help them adapt.
So what does all this mean for you listening? Well, it means these aren't just vague possibilities. These are active hiring programs right now with clear career paths. But to really make the most of it, you need to understand how the industry itself is structured. Where do these opportunities actually sit? Yeah, knowing the industry structure is, vital if you want to target your efforts effectively. Let's start with the big players, the small modular reactor developers. Take NuScale Power. They're focused on light water small modular reactors, big emphasis on passive safety systems, built for inherent safety, scalability. They've got over 700 employees, and they're hiring aggressively. Focus areas. Reactor design, manufacturing, licensing, project development. Just in 2024, they hired over 200 engineers, mostly mechanical, nuclear, and electrical. Then you've got TerraPower. They're known for their Natrium reactor. That's a sodium-cooled fast reactor. It integrates energy storage, which is pretty impressive. Designed for high efficiency, it can even use spent nuclear fuel. They have over 400 employees, growing fast. Their focus tends to be more on advanced reactor design, materials development, and construction. And they've got serious backing, over $1 billion from Breakthrough Energy and Department of Energy support. X Energy, now they specialize in the X100. That's a high-temperature gas reactor using TRISO fuel. TRISO fuel is unique. It's this robust particle fuel, inherently safe, handles super high temperatures, great for process heat applications. They have over 300 staff, big manufacturing focus. Opportunities there are around TRISO fuel manufacturing, reactor development, commercialization. They're aiming for over 1,000 employees by 2027. Ambitious. And finally, Kairos Power. They're working on a fluoride salt-cooled high-temperature reactor, FHR they call it, over 250 employees, their focus. Heavily into materials development, reactor testing, and licensing. They're really known for having the highest concentration of material science and nuclear and engineering brains in the business, really pushing the envelope on advanced materials.
Right, and beyond those developers, you have this whole ecosystem of major suppliers and contractors. They offer different kinds of roles, often more focused on the big project execution side, the foundational engineering. So on the manufacturing side, you've got companies like Doosan Enerbility. They're crucial for making reactor vessels, big components. BWXT is another big one, known for nuclear components, plus they have all that naval nuclear experience. Holtec International does heavy manufacturing, project development too. And Westinghouse, of course, a very established name. They provide nuclear steam supply systems, lots of services. And then there are the engineering contractors. These guys are critical for the design, the build, getting these projects licensed. You've got Bechtel, heavily involved in construction management, EPC, that's engineering, procurement, and construction services. Fluor brings a lot of know-how in nuclear construction project management. Burns and McDonnell, they specialize in engineering design, power plant construction. And Sargent and Lundy, they provide essential nuclear plant design and licensing support. A lot of experienced engineers find their way into these firms, applying their existing skills on these massive nuclear projects.
Exactly. And it's not just about building them, it's also about who uses them. Understanding the utility in the end user markets is really key because these are the customers, right? And they create different kinds of jobs operations, project development, business development roles. So on the utility side, you have some major customers lining up, like Utah Associated Municipal Power Systems, UAMPS. They've got that big 462 megawatt NuScale project planned. Energy Northwest out in the Pacific Northwest, they're involved in small modular reactor development. Tennessee Valley Authority, TVA, they're pursuing demonstration and deployment. And up in Canada, Ontario Power Generation is a big player with their small modular reactor deployment programs. But it's not just the electric companies. Small modular reactors offer solutions for a whole range of industries, too. The steel industry, for instance, is looking at them for process heat. Maybe hydrogen production helps with decarbonization. Chemical companies, exploring high-temperature process heat. That's a perfect fit for some of these advanced reactor designs.
Mining operations, especially remote ones, see small modular reactors as a reliable power source, maybe for industrial heat, too. And data centers, with their huge growing power needs, they're definitely eyeing small modular reactors for reliable carbon-free power. So the opportunities, they really cut across multiple sectors, broadens the whole career landscape.
Okay, so we've mapped out the industry landscape where the jobs are. Now, let's unpack the skills you actually need to, grab these opportunities. Fundamentally, small modular reactor careers build on existing engineering skills, but you absolutely need to add that layer of nuclear-specific knowledge. For mechanical engineers, you need a solid grasp of fluid mechanics, think reactor thermal hydraulics, heat transfer analysis. It's critical for how these passive safety systems work, the overall efficiency in these unique small modular reactor designs. Materials science is huge, understanding how nuclear materials behave, degrade, especially with all the new advanced materials coming in. Thermodynamics for power cycle analysis, efficiency, structural analysis for seismic design, pressure vessels, standard stuff, but with a nuclear lens. For electrical engineers, the focus shifts. Power systems, definitely. Grid integration, designing the electrical systems to connect smoothly to the grid. That's key. Control systems are vital. We're talking digital instrumentation and control, or I&C systems. They're increasingly digital, need extreme reliability for plant operations. Protection systems for plant safety, obviously. Power electronics for efficient power conversion, control, especially with some of the advanced power cycles being looked at. And then underpinning everything, the nuclear engineering fundamentals. Reactor physics, neutron transport, reactivity control, fuel management, nuclear safety risk analysis, accident analysis, designing safety systems to meet those tough regulations, radiation protection, that's health physics, shielding design, contamination control, and nuclear materials, fuel behavior, structural materials, corrosion chemistry specific to the reactor environment. It's a lot, but it builds on existing foundations.
Yeah, and you know what I found really striking when I was looking through the data? Some skills have this huge imbalance between demand and supply. It's almost like a fast track into these careers. Take nuclear thermal hydraulics. Apparently there's a 5-to-1 job-to-candidate ratio. 5 jobs for every qualified person. Digital I&C systems. A 4-to-1 ratio for engineers qualified in nuclear controls. Nuclear project management, super important role, a 3-to-1 ratio for experienced managers. And then health physics. It's staggering. 6-to-1 ratio for certified health physicists. Just a massive shortage there. So this isn't just about learning something new. It's about stepping into a high-leverage niche where your value is just amplified. You become critical in plugging the industry's biggest talent gaps.
Absolutely. And it's also really important to stress that your existing experience, it's incredibly valuable. Lots of transferable skills are in high demand. Quality assurance, for example. If you've got QA experience from aerospace or automotive, highly valued. That goes right back to the Sarah Chen story, right? Her Six Sigma background was exactly what they needed. Systems engineering from defense, aerospace, that transfers really well into nuclear. These are complex, integrated systems. Manufacturing engineering, especially from heavy industry, precision manufacturing that's crucial for the factory fabrication aspect of these advanced reactors, and strong project management skills. particularly if you have experience in engineering, procurement, and construction or general construction project management. Those skills are highly sought after to actually get these complex projects built. Now, beyond the technical side, nuclear careers have this unique requirement, a deep understanding of the regulatory side and a really strong safety culture. It's quite different from other industries. On the regulatory front, you need familiarity with National Regulatory Commission regulations. Things like 10 Code of Federal Regulations 50, that's for licensing nuclear power plants, 10 Code of Federal Regulations 52 for combined licenses, 10 Code of Federal Regulations 73 deals with physical protection, 10 Code of Federal Regulations 100 covers reactor site criteria. It's about knowing how to operate in this highly regulated space where safety is just paramount. And then there's the safety culture piece. It's about embedding this nuclear safety mindset. That means conservative decision-making, always having a questioning attitude, asking, what if? Professionals are expected to use human performance tools techniques to prevent errors, to participate in corrective action programs identifying and fixing problems, and contributing to a safety-conscious work environment where people feel comfortable raising concerns. It's more than just typical safety practices. It's like a core philosophy.
Right. And when it comes to proving you've got this commitment, this expertise, professional certifications are really important. The American Nuclear Society, ANS, they offer some key ones. Their Nuclear Criticality Safety Certification, for instance, requires 4 years of nuclear experience, plus you have to pass an exam. It's often needed for jobs in the fuel cycle, criticality analysis roles. Basically proving you know how to prevent uncontrolled nuclear chain reactions. Super critical. Another big one from ANS is nuclear safeguards and security. Needs 3 years of security experience, plus an exam. This is relevant for physical protection roles, cybersecurity roles. And having it can mean a 15 to 25% salary bump. It's a growing area, too, with all the focus on cybersecurity for critical infrastructure. Then there's the National Institute for Nuclear Certification, NIAC. They offer the Nuclear Uniformity Program. It's a 40-hour fundamentals course. Gives you industry-wide recognition for having that baseline nuclear knowledge. Good starting point. And specialized technical certifications, they carry a lot of weight, too. The Health Physics Society offers the Certified Health Physicist, or CHP. That's an advanced radiation protection cert. Requires a master's degree, 4 years experience, plus the exam. Having that CHP can add like $20,000 to $40,000 to your annual salary. And remember that shortage. It's severe. So this is critical for nuclear facilities, just like Sarah Chen found, right? Her health physics certification wasn't just paper. It plugged her straight into one of those huge talent gaps, made her immediately valuable, commanded a premium. And finally, the Project Management Institute's PMP Project Management Professional. That's highly sought after, especially if you combine it with nuclear facility experience. Nuclear project managers with PMP. They can earn $120,000 to $200,000 a year, sometimes even more.
Yeah, certifications are key. But beyond that, university programs and other academic routes provide that foundational knowledge and, just as importantly, networking opportunities. Leading nuclear engineering programs are obviously at the forefront. Massachusetts Institute of Technology, MIT, for example, they offer bachelor's, master's, PhDs in nuclear engineering. Strong focus on small modular reactor design, advanced materials. They have direct recruiting ties with small modular reactor companies. Now, tuition is around $58,000 a year, but there's usually significant financial aid available. The University of Wisconsin's nuclear engineering program is another top one. They have specializations in reactor design, health physics, nuclear materials, strong industry partnerships, too, with companies like NuScale. And what's really good there is they offer online and distance learning options. Makes it flexible for people already working. Plus, they have dedicated nuclear industry placement services to help graduates find jobs. But maybe a full degree isn't the path for everyone. There are alternative routes. Community colleges, for instance, offer 2-year nuclear technology degrees. These programs usually cost between, say, $5,000 or $15,000 total, take about 18 to 24 months. They can lead to technician roles, which are often a great stepping stone into engineering jobs later on. And then there are professional development courses. ANS offers short courses. University extension programs have non-degree nuclear courses. Vendors like NuScale and TerraPower offer their own training. And online platforms like Coursera, ADX have nuclear engineering courses too. Lots of options depending on your situation.
Okay, so you've got the skills, maybe some certifications. Where are these jobs actually located geographically? Small modular reactor projects, they tend to be clustered in specific regions. That's important for planning. Out in the western U.S., there's a lot happening. Utah, with a UAMPS NuScale project, 462 megawatts. Idaho, home to the Idaho National Laboratory, which is huge for testing and development. And Wyoming, site of the TerraPower Natrium Demo Project, the draw for these areas. Often a lower cost of living, great outdoor lifestyle, plus a growing tech scene. Then you look at the southeastern U.S. Tennessee is a hub. Kairos powers test reactors there. BWXT has manufacturing. South Carolina has the Savannah River site involved in development. North Carolina has a strong nuclear manufacturing base. The benefits there. An established nuclear workforce already exists. Living costs are generally lower, and it's often seen as a business-friendly environment. And don't forget Canada. Ontario is a major player. They've got the Darlington Small Modular Reactor deployment happening. BWXT is expanding manufacturing there. New Brunswick is also active with their power utility developing small modular reactors. Benefits up there. Universal health care, education perks, and often a clear path to permanent residency, if that's of interest. Finally, international markets are opening up. South Korea for manufacturing, maybe deployment. Romania has a new-scale project planned. The UK is pushing advanced reactors. If you're thinking international, you need to consider work visas, obviously. But that international experience can be a real career booster.
All right, and when we talk money, compensation. Small modular reactor salaries definitely reflect those nuclear industry premiums we mentioned, plus the excitement around new tech. For entry-level spots, maybe 0 to 3 years experience, nuclear engineers are typically looking at $75,000 to $95,000 a year. Mechanical and electrical engineers in nuclear, slightly similar ranges, maybe $70,000 to $92,000. Health physics techs, $65,000 to $80,000. Then you get to mid-career, say 5 to 10 years in, salaries jump significantly. Senior nuclear engineers, $110,000 to $140,000. Nuclear project managers, especially with that PMP cert, $120,000 to $160,000. Lead systems engineers, $115,000 to $145,000. Certified health physicists, $100,000 to $135,000. And for senior roles, 10 plus years experience. Principal engineers, $140,000 up to $180,000 or more. Engineering managers, $150,000 to $200,000 plus. Technical directors, $180,000 maybe up to $250,000 or higher. Business development roles often have strong base salaries plus equity potential. And beyond the base salary, don't forget other benefits. Stock options can be significant, especially in newer companies. Annual performance bonuses, often 10-25%. Comprehensive healthcare, retirement plans, tuition reimbursement, budget for attending conferences. It all adds up to a very attractive package. Okay, so skills, location, money. Well, what about networking? Building that nuclear initiative network is absolutely essential for moving your career forward. Active participation in professional societies, industry groups, that's key. The American Nuclear Society, ANS, is really the cornerstone. Over 10,000 members globally, 60-plus local sections holding meetings. Their annual conference is huge, 3,000-plus attendees, great for networking, has a career fair, student programs, definitely worth getting involved. The Nuclear Energy Institute, NEI, is more focused on policy, business development. Their conferences are good for higher-level networking. They also have career resources, a job board. For a global view, there's the International Association of Nuclear Engineers. Connects people from over 40 countries. They have technical committees, international conferences, even formal mentorship programs. And finally, you're seeing specific small modular reactor organizations pop up, like the SMR START Alliance. Their whole goal is to speed up small modular reactor development and deployment. Members include developers, utilities, suppliers. They do policy advocacy, support tech development, and run small modular reactor-specific events perfect for really focused networking in this growing niche.
Yeah, and attending conferences strategically isn't just about sitting in sessions. It's a huge networking opportunity. Shows you're serious about a nuclear career. That ANS annual meeting, it really is a must attend. Over 3,000 nuclear pros. Technical sessions, yes, but also that big career fair, programs for students. Okay, it might cost $1,200 to $1,500 including travel, but the return on investment for your career can be massive. Another key one is the Nuclear Energy Assembly. This one leans more towards the business and policy side. You get C-level execs, utility leaders, policymakers attending. Great for high-level networking, getting real industry insight, especially if you're eyeing business development or senior roles. And beyond those big ones, look for those small modular reactor-specific events. The Small Modular Reactor Knowledge Hub, the Advanced Reactor Summit, events by the Nuclear Innovation Alliance. Attending these lets you make really targeted connections, get insights into specific projects and companies. Okay, that's a lot of information. Let's try and break this down into a concrete action plan, something you can actually use over the next year. Let's map it out, months 1 to 3.
Think foundation building. First, assess yourself. Do that skills gap analysis using the framework we talked about. Research companies, figure out where you might want to live, identify, say, 3 to 5 specific small modular reactor roles that fit your background. And critically, update your LinkedIn profile. Make it nuclear focused. Highlight those transferable skills. For initial training, enroll in a Nuclear Fundamentals course, NIAC, or a university extension maybe. Join the American Nuclear Society. Find your local section. Start reading nuclear news, other industry pubs. And go to those local ANS meetings. Start networking right away.
Right. Then, months 4 to 6. Focus shifts to skill development. Continue that formal education, finish your fundamentals course. Now is the time to enroll in a relevant certification program, maybe health physics, nuclear safety, whatever fits your path. Look into online nuclear engineering courses on Coursera or ADX to supplement. And definitely try to attend your first major nuclear industry conference during this period. Expand your horizons. On the networking front, ramp it up. Connect with maybe 50-plus nuclear professionals on LinkedIn. Get more active in your ANS local section, maybe volunteer for something. Try to identify 3 to 5 potential mentors and companies you're interested in. Join those small modular reactor-specific LinkedIn groups and actually participate in the discussions. Deepen knowledge, expand your circle.
Okay, month 7 to 9. Now it's about specialization and application. Aim to complete that first nuclear certification or advanced training program you started. Attend a small modular reactor-specific conference or workshop to really dive deep into your chosen area. See if you can get vendor-specific training from NuScale, TerraPower, others. And a key step here, develop a nuclear-focused project portfolio or create case studies showing off your new skills. Job market time. Start setting up informational interviews with people at your target companies. Learn more, make connections. Begin applying for relevant small modular reactor jobs, maybe 10 to 15 to start. Hit the nuclear industry job fairs, recruiting events, and build relationships with nuclear recruiters so they can be huge allies.
Exactly. And finally, months 10 to 12, this is the career transition phase. Final prep time. Finish up any remaining certification requirements. Really polish that nuclear industry resume. Practice your interview skills, know your story, your value. Secure solid references from people within the nuclear industry. And when those job offers come in, negotiate carefully. Look at the whole package compensation, growth potential. But it doesn't stop there. Ongoing professional development is key. Once you land a role, plan your next steps. What advanced certifications or education make sense? Develop a 5-year career plan. Where do you want to be? And importantly, think about mentoring others coming into the field. Pay it forward. It really solidifies your own place in the industry.
So the bottom line for your small modular reactor career, it's pretty clear. This industry, it really is the biggest career opportunity in nuclear energy since the original build-out in the 1970s. But unlike back then, today's small modular reactor scene offers way more diversity. Different technical paths, lots of geographic options, companies at all different stages. Success, though, it requires that deliberate planning, getting the nuclear-specific training, and networking strategically. But the path is there for engineers like you to build really rewarding careers. Good pay, yes, but also making a real impact on energy.
Yeah, and the return on that investment, it's really compelling. You might spend, say, $5,000 to $10,000 over 12 months on training and certs, but that can lead to 20 to 40% salary increases. Plus, you get access to this rapidly growing industry, over 80,000 jobs expected by 2030. The timing right now, it's kind of optimal. The industry is established enough to offer stable careers, but it's still early enough that if you get in now as an early adopter, the growth opportunities can be exceptional.
So this week, we've really dug into the small modular reactor revolution. And the conclusion seems pretty clear. Small modular reactors are a fundamental shift in nuclear energy. They're creating unprecedented career opportunities, but for engineers who are willing to invest in those nuclear-specific skills and knowledge, the pathway exists. The opportunities are definitely real. The big question is whether you'll make that investment. Building the nuclear expertise that positions you for success. Your small modular reactor career, it really starts with what you do in the next 30 days. The industry needs your skills, but enhanced with nuclear know-how, demonstrated through that professional commitment. So what's your next step? Are you ready to invest in the training, the networking that opens the doors in nuclear energy's most promising sector? And that wraps up our week-long deep dive into the small modular reactor revolution, part of the High Voltage AI podcast series. If you'd like to leave feedback, or if you have any questions, feel free to reach out to our producer, Julius Guay, that's G-U-A-Y, pronounced Guay, on LinkedIn.